All right. How are the quotient and product rules related? So the product rule states that the derivative of f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x. While the quotient rule states that the derivative of f of x over g of x equals f of x, f prime of x times g of x. G of x minus f of x times g prime of x over g of x squared. Now, when we get so if we try to find the derivative of two functions being multiplied, we use this. And if two functions are being divided, we use this. But the derivative of f of x over g of x, this can be written as the derivative of f of x times g of x to the negative 1. Put that in parentheses. Now, we can use the product rule to solve this. Now, so which means this will be equal to f prime of x times g of x to the negative 1 plus f of x times g of x to the negative 1 prime. We use the chain rule to solve this, so we move the negative 1 to the front. So we first find the derivative of since g of x is within these parentheses being multiplied by negative 1, the first function is x to the negative 1, so of g of x. So we first find the derivative of that. We move the negative 1 down, so negative 1 times, we have g of x to the negative 2, because we're subtracting 1 from negative 1 from negative 1. So g of x to the negative 2 times g prime of x. Now, if we move our g of x's down, it will mean that f prime of x over g of x minus, because we move this negative 1 to the front, f of x times g prime of x over g of x squared. Parentheses g of x squared. Now, finally, we can multiply each of these by g of x to get f prime of x times g of x minus f of x times g prime of x over g of x squared, which looks exactly like the quotient rule. So from the product rule, we proved the quotient rule. That's how they were related.